In this video, we're going to learn how to find the inverse of a logarithmic function. Now, to find an inverse, you switch x and y and then solve for y. Now, I mentioned in the last video that logarithmic functions are inverses to exponential functions, and you're about to see that come to play in this video. So if I wanted to find the inverse of y is equal to log base 4 of x, my first step is to switch the x and the y's location. So x is equal to log base 4 of y, and then just solve for y. So now I want to get y by itself. Now the best way to get that y by itself is to switch this to exponential form, which again, logs are equal to the exponents you raise the base to get the inside number y. So I can rewrite this as 4 to the x power is equal to y, and now that I've solved for y, I can see that my inverse function, I can write f inverse of x is equal to 4 to the x, an exponential function. So very clear that these two functions are inverses. Now let's look for something with another step involved, because sometimes they don't go as quickly as that. Let's say we have log y is equal to log of x plus 1. So we're going to start by switching x and y. So we have x is equal to log of y plus 1. And now we'll solve for y. I want to rewrite this so it's not in logarithmic form so I can get to the y part of it. But I don't know what the base of that log is. Now when you're not given the number, that's assumed to be log base 10, the common logarithm. So when I rewrite this in exponential form, this log is equal to the exponent you raise 10 to get y plus 1. So 10 to the x is equal to y plus 1. And to finish solving for y, I'll subtract 1. So 10 to the x minus 1 is equal to y. So my inverse function, f inverse of x, is equal to 10 to the x minus 1. Now, for log base 5 of 2x minus 6, I'll do the same start. I'll switch x and y. So x is equal to log base 5 of 2y minus 6. So to rewrite this in exponential form to get to the y and get it by itself, I know that x is the power I raised 5 to get 2y minus 6. So 5 to the x is equal to 2y minus 6. Solve for y, I'll add 6 to each side. So I'll have 5 to the x plus 6 is equal to 2y. Then I'll divide each side of my equation by 2. Or it's the same as multiplying by 1/2. Now it gives me y is equal to 1/2 times 5 to the x plus 3. So that's what y is equal to. So my inverse function, f inverse of x, is equal to 1/2 times 5 to the x plus 3. And for the last one, I have y is equal to negative 1/2 log base 3 of x minus 4 plus 5. So I start out by switching x and y. So now I have x is equal to negative 1/2 log base 3 of y minus 4 plus 5. And one key component here that we haven't experienced yet is that the log didn't start out by itself. I need to get it by itself first before I could finish solving. So I'll subtract 5. So I'll have x minus 5 is equal to negative 1/2 log base 3 of y minus 4. Then I'll multiply each side of my equation by negative 2 to get rid of that negative 1/2. So negative 1/2 times negative 2 is 1, so that now goes away. Distributing the 2, I get negative 2x plus 10 is equal to log base 3 of y minus 4. Now that I have this logarithm by itself, I can get to the y by rewriting this in exponential form. So negative 2x plus 10 is the power you raise 3 to get y minus 4. So 3 to the negative 2x plus 10 is equal to y minus 4. And to finish solving it, I'll add 4. So I'll get 3 to the negative 2x plus 10 plus 4 is equal to y. And that is my inverse function. So f inverse of x is equal to 3 to the negative 2x plus 10 plus 4. And that is how you find the inverse of a logarithmic function.